So our next problem is problem number 12 of the MIT integration book of exam 15, which is the indefinite integral of 1 over the square root of x squared plus 25. So let's, it's fairly long, but I think we may be able to finish it pretty quickly. Let's see how we would solve this. So the indefinite integral of 1 over the square root of x squared plus 25 is our problem. And we may want to maybe do a substitution, bring in a trigonometrical substitution. And I see 5 tan x in place of x being the appropriate substitution. So let x be equal to 5 tangent theta. So what this means is that dx d theta is equals to 5 sec squared theta. And that means that we can substitute dx with 5 sec squared theta d theta. This is C. So important substitution. So what that means is this problem becomes, in the theta domain, in place of x we have 5 squared tan squared theta plus 25. In place of dx we have 5 sec squared theta d theta. So this becomes, since we have 1 over square root of 25 tan squared theta plus 25, 5 sec squared theta d theta, we can pull this 25 out and it becomes 5, and we're left with tan squared theta plus 1 theta. So tan squared theta plus 1 is the same as sec squared theta, but we have a square root sign, so we have 1 over sec theta, and then we have sec squared theta in the numerator. So this and the square goes, and our problem now becomes the integral of sec theta. So this is okay. We can solve this. So if we write sec theta as 1 over cosine theta, we express it in the half angle formalism. So cosine theta is the same as cosine squared theta over 2 minus sine squared theta over 2. Right? So our problem is that, and when faced with such a problem, the best substitution is by letting t be equal to tangent of theta over 2. So if we have theta over 2, and what we have here is t is the opposite, the hypotenuse is 1, the tangent of the base angle is the same as opposite over the adjacent, and the hypotenuse becomes 1 over t squared square root, such that cosine squared theta over 2 is the same as adjacent over hypotenuse squared, which is 1 over 1 plus t squared. Obviously square root squared becomes that, and sine squared theta over 2 is the same as this opposite squared over hypotenuse squared, so we have t squared over 1 plus t squared. So our integral becomes 1 over, we forgot to do one thing, and that is how may we express the theta, and that is from here we see d theta is the same as a half sec squared theta over 2. So 2 dt over sec squared theta over 2 is equals to d theta. And sec squared theta is the same as, since we have 2 dt over sec squared theta over 2 being equal to d theta, we know sec squared theta over 2 is the same as tan squared theta over 2 plus 1. That means 2 dt over t squared plus 1 is equals to d theta. So important substitution. So what that is that our integral of cosine squared theta over 2 minus sine squared theta over 2 is the same as 1 over 1 plus t squared minus t squared over 1 plus t squared 2 dt d theta here over 1 plus t squared, which is the same as 1 plus t squared when this and this go up over 1 plus t squared 2 dt over 1 plus t squared, and that would cancel, so we're left with twice the integral of 1 minus t squared. So it is the same as, so we have the integral of 1 minus t squared, which is the same as 2 1 minus t 1 plus t, which is the same as 2 integral over half 1 over 1 minus t plus 1, and that too would cancel. So we have our integral of 1 minus t plus 1 over 1 plus t is the same as negative natural logarithm of 1 minus t plus natural logarithm of 1 plus t plus c, which is the same as log of 1 plus t over 1 minus t plus c. And since t is equals to tangent of theta over 2, integral becomes 1 plus tangent theta over 2 over 1 minus tangent theta over 2 plus c, which is the same as log of cosine theta over 2 plus sine theta over 2 cosine theta over 2 minus sine theta over 2 plus c. It's the same as log cosine theta over 2 plus sine theta over 2 times cosine theta over 2 plus sine theta over 2 over cosine theta over 2 minus sine theta over 2 cosine theta over 2 plus sine theta over 2 close bracket plus c, which is same as cosine square theta over 2 plus sine square theta over 2 plus 2 sine theta over 2 cosine theta over 2 over cosine square theta over 2 minus sine square theta over 2 plus c. It is the same as log, since we have cosine square theta over 2 plus sine square theta over 2 plus 2 sine theta over 2 cosine theta over 2 over over 2 plus c. This part here is the same as 1, this part is the same as sine theta, this part is the same as cosine theta. So we have log 1 plus sine theta over cosine theta, so which is the same as So since we have log 1 plus sine theta over cosine theta plus c, same as log sec theta plus tangent theta plus c, and we had indicated that let x be equal to 5 tangent theta. What this means is that if you have an angle, this angle theta, and we have x over 5, because this means that x over 5 is equals to tan theta, and tangent of theta is opposite over adjacent, then we have x squared plus 25 as the hypotenuse. And so maybe if we go back to this point here, sine theta is the same as x over square root of x plus 25, opposite over hypotenuse, and cosine theta is the same as 5 over square root of x squared plus 25, adjacent over hypotenuse. So since our answer was 1 plus sine theta over cosine theta plus c is the same as log of 1 plus sine theta, we determined to be x over square root of x plus 25, and then cosine we determined to be 5 over square root of x squared plus 25. So it becomes log of square root of x squared plus 25 plus x over 5 plus c, which is the same as log of x plus square root of x squared plus 25 minus log 5 plus c. This can be bunched together as another constant c, so our answer becomes natural logarithm of x plus 20 square root of x squared plus 25 plus c. So in other words, our integral x squared 1 over x squared plus 25 is the natural logarithm of x plus square root of x squared plus 25. That's the integration constant. See. So that's the answer. Thank you so much. It was a little bit windy, but all the same interesting.